Hello and welcome to week 4 of Information Technology, Importance in Strategic Planning. This will be a fairly busy week. This week we have our fourth lecture, but we also have the first case study due and a midterm exam. So just a moment on both of those. The case study, there are 4 that I've posted online. You pick one of those 4 and you answer the short answer questions therein. And then for the midterm, it will be a combination of true false, multiple choice, short answer like questions, and there will be a time limit imposed on that. Ideally, you will have studied and reviewed all of the course material, whether it's in reading or the lectures, and be ready for it. If you have any questions, feel free to post them on the discussion boards, and I'll address those via the discussion board. So this week is about 2 things, IT architecture and infrastructure and IT security. So let's start with architecture and infrastructure. Now I put here vision without execution is delusion, and that's because very frequently there's a dichotomy that exists in the information technology space. On one end you have architecture, and on the other hand or end you have delivery. And those two are in constant tension with one another. You have individuals who tend to gravitate toward each, and so the architects will look for what are the main building blocks that we have to deliver, and oftentimes they will seek perfection. On the delivery side, usually what you see there or hear there is just get out of my way, I want to start coding, and they are about really getting down into the brass tacks of delivery. And what you really need to be successful is a balance of both. A technology leader should understand where inside the various roles they reside and recognize as you get higher and higher in senior levels of IT leadership that you have to look outside of your functional area of responsibility and think about that balance and seek to obtain it. And you're going to hear when we talk about IT security that sometimes IT security gets in the way of experience or productivity, and there's a great example of one of those balances. So you have to always look at what's the long-term vision and what's the near-term execution, balance those together, and that's how you get to this idea of combining vision and delivery with execution. Now, it may be challenging if you haven't been in this space before. How do you think about architecture? And the classic example is given around buildings. So you start out with someone who says, I need something. It's a building, and you usually sit down with an expert in building and you design out what that experience should look like. It may be or result in a set of plans, which are blueprints that are then implemented by the builder, the individual that is bringing it together. Irrespective of that, it can be challenging to go from this idea of what is it I want out of something down into the actual brass tacks of detailed choices, such as where do outlets get put, what kind of outlets are being used, what kind of wiring is necessary, plumbing, how does the plumbing exit the structure, how do you bring it all to that one point, how do you think about plumbing when you're laying a concrete slab. So there's quite a bit of thought process that goes into it, not all of which is up front. And what guides that at times can be a variety of standards, for instance, that denote the kinds of things that have to be used in order to deliver on a structure. So you have a little bit of knownness, if you will, and a lot of I'm not so sure about what I'm looking for. But as you go through this process of detailing out architecture and infrastructure, ideally you go from the general or more abstract, the building blocks, if you will, down to the specific detailed plans on how you bring that vision together. And so in the IT organization or sphere discipline, you start with a strategy, you develop an architecture which serves as the blueprint for the implementation of the infrastructure. And the authors have a very interesting definition of infrastructure, and I'll touch on that in a few slides. But what must the manager do in this process of going from strategy to architecture to infrastructure? Well, first they have to clearly communicate the business vision, which manifests itself in the form of a business strategy. And they need to understand what to expect from the IT architecture and infrastructure. And this is very important because if they don't understand it and they get a particular outcome that somehow impedes the long-term vision for the business, there's a dual accountability. Oftentimes people fail to understand that. If I ask someone to do something for me, they take on the responsibility. They become accountable for doing that. But I carry a responsibility and accountability to follow up to ensure that they understand what I've asked and that they actually are delivering or producing that which I ask. So accountability has those two sides, and this is often not well understood in the business place, because folks believe if I ask you for something, then my responsibility or accountability with that ask is finished, and it really isn't. And therefore, when a manager, a general business manager, is working with their IT counterpart, they can say, this is what I am looking for. That can be taken and understood and played back by the IT leader, but it's the business person that must understand, well, what are the implications of that? What can I expect from that? And then obviously, you have to modify plans if it's not feasible for technology to meet those expectations. This could be as simple as a response time expectation. And you see this as folks have moved from a traditional mainframe where a 3270 screen might respond in sub-second response to today's web-based experience where you may have 2 or 3 seconds for the web page to come back and paint. You have business users who will sometimes say, I want it in less than a second. And it's just not practical for that to happen, especially with the complexity of the tools and capabilities today in their ability to bring large amounts of information together and present it on a single screen that then can be navigated through point and click and scroll. And then obviously the manager must be involved in the decision-making process. At the end of the day, that is how they ultimately own the accountability for that which they've asked for. In essence, the ultimate is in the acceptance or the approval process, where the manager must explicitly take on and accept the solution that's been developed and prepared for use. So there are a set of principles that you should think about as you think about architecture. And these vary. Different organizations have different perspectives, but clearly this is a good set to think through. Ease of use. You'll hear me talk more about flexibility, maintainability, and so forth. Architectures almost have to be the basic building blocks, which suggests that you can take them, plug them in, use them, unplug them, and plug other things together. So you need to have that ease of use for architecture. A single point of view, oftentimes you'll hear this mentioned around you should have a system of record mindset. And the system of record says, this is where I go. This is my source of truth for something. Imagine if you didn't have a single place to go to understand someone's address in various banking systems. So you have a checking system, you have a credit card system, you have a savings system. Brian Leclerc exists in all of those systems. But imagine how much confusion there would be if I wanted to change my address. Do I have to go to 3 places? Do I have to go to 1 place? Or do I have some mechanism to marshal that system of record? Now, systems of record are different than systems of differentiation, and the system of differentiation is how does that business in its practice differentiate itself from its competition. A unified account back in the early days of financial management was a differentiating capability. Customer relationship management system is a differentiated capability. It's not a system of record necessarily. Now it may interact with a system of record. And then you also have systems of innovation. And this is really on the edge where capabilities start to come to high value for the customer, the consumer in that experience layer. And I'll talk a little bit more about this when we get into architectures and how to think about this idea of creating an ability for rapid innovation on the edge. You have questions like, do I partner before buy? Do I buy before I build? And architecture should give guidance as to how to deliver on those capabilities, but a principle of the looking at each of the building blocks should be this idea of partner before buy before build. Speed and quality, always an emphasis, irrespective of architecture, but the ability to deliver quickly so you get speed to value, and quality is really around the experience. I alluded to flexibility and agility. This is the building blocks, the ability to unsnap one component and snap a new or different one in. I talked a bit about innovation, the ability to deliver an experience that's rapid, that really has high speed to value. How does one do that? Typically, that's not done inside systems of record. And you will hear this in organizations that have large legacy or heritage systems and that were not built to be as open as others. So this whole idea of architecture and creating this openness, this plug and play capability, it sets the foundation on which everything is built. Data security or security in general, it isn't just data, it's also access to capabilities, has to be a primary principle. This idea of a common data vocabulary is around how do you get individuals speaking about and talking about things in the same language. And that is really not a well understood but very important. If you were to roll the clock back 15 years, you may find that different business segments that operated mostly physically separate may have and use language for the same thing. An example in the healthcare space is a medical claim and a dental claim historically were referred to as different things. You had a medical claim and a dental bill. And that works fine when you have physically separate experiences. But when you start to bring those together into a web-based experience, you now have to ask the organization, that thing that you're going to show them, is that going to be a dental bill or a dental claim? Is it a medical bill or a medical claim? And it sounds really simple, but you train certain behaviors and you do that with your customer, your users. So a common vocabulary inside the organization helps set the stage for outside the organization. Data quality is clearly an important point. You will find that a business process will view data specific to its use and its consumption. And data generated from that process, for instance, an enrollment process, may be useful several steps down into the experience journey for the consumer. And I may not, because it might affect my operational speed, stop to capture data early in that enrollment process. And if I don't do that, and it's then missing later in a subsequent process, the ability to get that data later becomes extremely costly. And if I don't have the right validation, it actually can create a lot of problems in that follow-on process. An example of this is if I am getting someone to enroll in a product, they've purchased the product, and I don't get their contact information, which may be not even relevant for selling the product or enrolling that individual. But later, because of an adjunct process, I want to reach out to that consumer, then I may be missing that very important piece of information that I could have obtained and validated, but because of efficiency in the earlier process, it's overlooked and not understood its value till the subsequent process. And because those process owners may be different, you may get to a point of structural tension where one of the process owners is trying to get another process owner to introduce capture of that information and its validation in the earlier process. And very frequently, you'll see a data governance organization who will champion the value of an investment in an upstream process because of the value in a subsequent or downstream process. And so data quality is a very important part of that. And together, quality and viewing data as an asset is why you see a lot of organizations building out data governance organizations as champions to work across these processes, in essence, to sell the business case for technology investments that may slow down an earlier process, but actually benefit the overall experience of the consumer in a subsequent process. And the simple example is contact information, getting it up front rather than trying to get it downstream, where its use may be valuable in reaching out to engage, for instance, in the healthcare space, a patient in self-care. So I'm going to walk you through this idea of the steps that one goes through around moving from strategy to architecture to infrastructure. So you start with your business strategy, and that's used to develop very specific goals. These are business outcomes. This is what I want to happen next year, the year after that. And there's a whole big debate around what is the planning time frame. A lot of companies prefer to compare themselves to a Google anymore, where they may talk about product schedules or releases that only go out 6 to 9 months, and they're not specific beyond that. That doesn't mean that they don't have goals that lay out on a multi-year journey. They may balance how much of investment they place in getting to details. I know in our case, we look at a 12 to 18 month time frame, even though we're laying out plans that will have a 4.5 to 5 year time frame. Clearly, 12 to 18 months is taken more through the details I'm going to walk you through, as opposed to the further out years where you stay at a higher level, you speak more toward rough orders of magnitude around investments as to having specific requirements or features defined. So goals, again, are business outcomes, and then you get to specific things that you have to do or want done in order to produce that business outcome, which manifests itself in a business requirement. Now, I used a language where I talked about this idea of features and requirements, but today, frequently you'll hear about these things as business capabilities. These are the able tos. And so 12 to 18 months, you get into very specific abilities, which may feel more like features and business requirements. As you get further out, you now get into broader capabilities. You have an ability to, I'll make this up, digitally enroll a patient, as an example, versus a very specific near-in requirement that says, I want to be able to see consistent information in my associate portal so that I can adequately service a member. And that information has to do with enrollment information, claim information, and so forth. Much more detailed, much more specific. And so the book will lead you to believe that this is a very linear process, and generally it is. Typically, strategy will start out with a competitive scan of traditional and non-traditional competitors It will start out with a technology scan around what are the macro trends in technology. Then it will get to an understanding of where our existing business capabilities lie, and then juxtaposing those against the goals, the business outcomes that you strive to achieve that are tied to your business strategy. You look for where are the critical gaps. And those critical gaps are filled through specific business capabilities that change from where they are today to tomorrow. If you're talking 6 to 9 months, those may feel more like business requirements. If you're talking 6 to 12 to 18 months, they may feel more like features, major features. And when you get further out, they feel like more like capabilities or Uber capabilities. Again, hopefully you have a sense for your level of precision closer in is much higher, and as it goes further out, your confidence interval around your estimates will get larger, and as such, you will see larger estimates further out. And oftentimes you manage those by stage gating your way through your investments over time, and you'll hear this when we talk about IT governance in the next lecture around portfolio management. So this set of nearer in requirements, features, major features, and capabilities, the technology organization will typically take a step back and look at those and develop a view toward what are the technical capabilities that are necessary. An example may be we need a single internal identifier for our consumer. That may seem simple, but go back to the example of we may have Brian LeClaire in a checking system, Brian LeClaire in a savings system, Brian LeClaire in a funds system, market fund system, mutual fund system. And this one may refer to folks internally with an 8-digit number. This may with a 10-digit number. That might be with a alphanumeric that's 6 characters long. And you say to yourself, it seems really simple, but again, this idea that we want to give our customers a unified experience that manifests itself in the form of a business capability may then turn into a technical capability that says, I now need a unique identifier and an ability to ensure that I create this master index where I bring Brian LeClaire, even though he has 3 individual identifiers in 3 separate systems, to where I have a unique identifier and a marshaling process and technology that's used to bring that to fruition. And that may form my consumer 360-degree view, which is, again, a major building block that may find its way into the architecture. So these requirements, features, and capabilities will translate into specific technical capabilities. Those technical capabilities will be bundled together into the basic building blocks of the architecture, and that will then set forth the blueprint for how the infrastructure components as defined in the textbook are brought together. And that gets into, you heard me allude to this idea of marshaling individuals, the ability to create a reconciling index. All of those form some variant of a functional specification. Again, when you get to nearer in, what are you doing in 6-month increments? You get functional specifications. When you get farther out, they may manifest themselves in overarching technical capabilities whose functional specifications will be developed over time as opposed to as part of the IT strategy. That then turns into very specific needs around the hardware, software, and other fronts, which I'm going to speak to here in a few minutes. So the textbook takes infrastructure and breaks it down into hardware, software, data, and network. And you can understand why. Uh, Hardware is really about the physical devices. Hardware could be a laptop, it could be a desktop, it could be an open systems, a Windows server. It could be a mid-range server, such as a Unix or a Linux box, or it could be a mainframe. But it's typically a tangible device on which you can compute and store results. And of course, on that device, that's when you compute, you use software to compute, and when you store, you have data. And then those devices are interconnected and communicate with one another, which is where the network elements come from. So at the end of the day, that's the lowest common denominator for describing what could exist or take place inside of infrastructure. And I have a slide where in a little bit that will hopefully clarify a number of these concepts in a little bit more detail than the book goes into. The book talks about this what, who, and where of infrastructure, and these are choices that you often think about as you translate your strategic blueprint into its implementation in reality. And so you get into questions of what types of hardware, what types of software are you going to be developing, what types of data are you going to be storing, what networking capabilities must you have. You then get into who is accountable for them, who manages it, who uses it. There's this phrase of owns it, and oftentimes ownership is aligned more with managing as opposed to using. But you can have circumstances where business areas will own hardware. And if that is not governed, which is again in an upcoming lecture, you can get into a decentralized space, oftentimes in centralized organizations that'll be referred to as shadow IT. And then the where, and all of these things get toward further defining the requirements of the underlying infrastructure and what you must do in order to properly deliver it, maintain it, and secure it. So I talked about different ways of thinking about infrastructure, and the book describes it in an academic way. I think about it as translating from some of the concepts that the book presented into, you may look at first, you think about infrastructure. Infrastructure can be separated from engineering. So the book doesn't draw that big of a distinction. In fact, it bundles engineering up inside of infrastructure. So the technical manifestation of information technology in the book is infrastructure. When you think about where that is run, where is the hardware, the software, the network, and data stored? There are traditional views toward that. Oftentimes, they're thought of as fixed capacity, and this is where you hear the phrase data center. So the heritage of infrastructure is most organizations either were large enough that they could build their own data center, or they would lease space inside of someone else's data center. It generally had fixed capacity. Now it was variable, but it was variable in stair steps. And oftentimes each step was costly and took a long period of time to deliver because it was more like fixed equipment. You would have to acquire boxes, servers, you'd have to install them, you would have to lay lines, you would have to create the servers, buy them, install them, configure them for storing data, and oftentimes the cost was high. your cost was a function of your buying power, which was typically tied to organizational scale, and it was it was not necessarily easy to ramp up capacity quickly in a short period of time. It would typically take months in order to do that because of the procurement process, the installation, configuration, and prep necessary. Now, you could view those as centralized or decentralized, where it's run in one data center, one complex, or it's run in multiples. Most companies that operate decentralized do so either because of acquisition or sheer scale or size any longer. Then you have this thing called the cloud. I'm going to speak a little bit more about this, where you have a much greater degree around your variability for garnering capacity. Now, the cloud can take form in that it could be private. Many companies have taken their traditional data center infrastructure and converted it into the private cloud. What that means is they typically have a higher degree of capacity than they at any point in time require, and they have tools that allow them to provision much more quickly than traditionally. In other words, they are using software to leverage their physical infrastructure such that they have a lot of, not a lot, that's probably too extreme. They have capacity that would allow them to provision quickly from within the capacity through software. You have public, easy there is Amazon Web Services, where you have the ability to dial up and dial down on capacity very quickly and easily. This is because companies like Amazon, Apple, Google, IBM, other cloud service providers have invested heavily in data center capabilities. Typically, they are centrally managed but very distributed globally in a number of cases. Many of them are so large that they have implemented, for instance, windmill generator power to power these data centers, or water turbine power, and in some cases sell that back to the electrical companies. And so implicit in their business plan has been to build what would have been thought of as traditional data centers, and then used software to drive a high degree of compression of capabilities into those footprints, and these tools to allow for the quick provisioning and deprovisioning of capabilities, hardware, software, network, and so forth. And for companies that are smaller, it's allowed them to compete because they don't have to have the capital requirements that a larger company has or would have to have in order to implement large-scale infrastructure. Most companies today, larger companies, are operating in a hybrid environment. I know at Humana we do. Networks, you have to think about, how do I connect to the broader world, and then how do I connect inside my world, and that's the difference between wide area connectivity and local area. You have a variety of means for connecting. You could have wired, you actually could have fiber, and you can have wireless. Most companies today operate across a spectrum of network connectivity. Then you get to application architecture. This is, so on the devices, on the boxes and wires, this is how do I structure the application. So you do have application architecture as well. You can have peer-to-peer, where these solutions share responsibilities in what they do, and they communicate one to the other, and they're not necessarily structured explicitly like client-server, where a client communicates to server, server gets the work, sends it back to client, or tiered, where it may be you have a browser that goes to a web server, the web server will go to an application server may go to multiple application servers, which ultimately goes to a database or some other interoperability play. Result comes back as aggregated and sent back. And then I just mentioned interoperability, and there are different ways that systems solutions can communicate with one another. Application programming interfaces, you hear quite a bit anymore, primarily in the mobile space, where you have one of these devices that has an app on it that connects to APIs across many times multiple organizations, companies, and many times within a company through application programming interfaces. You may have a services-oriented architecture that publishes services, an enrollment service, an eligibility service, for instance, or may break those down into microservices. And frequently you have APIs that sit on top of microservices. And then you have message-based, which is you have a mechanism to construct a message, which is in essence a request for something to be performed, which is laid on a messaging bus that may be implemented with something like MQ series from IBM. The message is sent off somewhere. A broker receives it, decides what to do with it, invokes some functionality, bundles the result up, and sends the result back. And so it's a little bit delayered from the physical implementation. So again, you have the configuration for your infrastructure. You have the way the networks are connecting. You have the applications and how they are architected inside of that physically connected infrastructure. And then you have ways in which applications can communicate one to the other. Now, sitting behind this, and I alluded to this, is this world of where software is becoming the capability. Perhaps the best example of where that's coming to fruition is on these devices, where what you have is you have this idea of a camera, you have a flashlight, you have candles, you have magnifying glasses. You used to have multiple hardware devices that are finding their way into one physical device, and that is that process of taking something that was hardware and creating the appearance of that on top of hardware, but in software format, is called virtualization. And that is what is behind, in essence, this move to the cloud. And virtualization is, in essence, the ability to create something that is easily satisfied via on-demand. And so while I have a desktop at work, it's a Surface Pro device, I don't physically have a desktop. That, when I'm sitting in my office, is a means for me to access my desktop. My desktop is actually virtualized inside of our infrastructure, and I can bring that same desktop up on my my iPhone. I can bring it up on my iPad Air, my iPad Mini. I can go to a browser, and so what you have is you have this virtualized desktop that, when I go from device to device, brings up my desktop exactly in the form that I left it. Apps open, PowerPoint open. The only requirement in that particular case is I have to have some connectivity from the physical device to my virtual desktop interface that's running in the Humana Cloud. And inside of that Humana Cloud, there are a variety of servers, and those servers are running on physical servers where the servers themselves have been virtualized. And what that allows me to do is it requires me to have fewer physical devices, servers, than I would to otherwise need to have. Because if you think about it, every server that you have generally does not run at full capacity. And so if I can take a server that's not running at full capacity and run it on another physical server with other servers that aren't running on full capacity, I can get compression rates upwards of 5, 10, or even 15 times. And what that means is I give the appearance of having 15 physical servers they're actually 15 virtual servers, running on one physical server, and that compression ratio saves footprint, power, cooling. There are a lot of positive benefits to that. And this can be done at the mid-range level and in the mainframe level. You may have heard of the use of LPARs, logical partitions, on a mainframe. Well, that's just a means to allow your infrastructure to believe there are multiple mainframes, even though they're running on a single mainframe. Networks are becoming highly virtualized, software-defined networks. And the point to all of that is that the virtual server is, in essence, has an image that's in data that is stored and persisted over time. And it means that infrastructures are starting to become progressively more just general compute as opposed to bespoke engineered devices. And you see this in the network space where you think about switches used to be a highly specialized engineered piece of hardware, and now it's becoming more general purpose, and the software is performing the switching as opposed to physically engineered components on the device. So virtualization itself has spawned a whole set of industries wrapped around it. Frequently, these are industries that offer cloud-based services. Three of the more common ones you'll hear about are infrastructure as a service, Amazon Web Services. This is where I may be a startup. I don't have the ability to build a data center, buy all of these devices, connect them together, all of the resource necessary to make that happen. As long as I have a credit card and I can go to Amazon Web Services, I can spin up my own infrastructure, and I can dial it up, meaning I can buy more servers and I can retire servers depending on my workload. So I am what's the phrase is called is I'm paying by the drink there. Platform as a service, this is where I can build and deliver technology solutions. Now I'm moving up into the software space. The infrastructure as a service was more about boxes and wires. And as I start to think about developing and engineering solutions and doing that inside of an existing platform like a Pivotal Cloud Foundry, I can build mobile solutions inside of a consistent platform. And that in and of itself is hosted in the cloud. And a lot of the operational aspects of what used to separate a development organization from the infrastructure organization have actually gone away, because a lot of that's built into the software capabilities that are leveraged inside the platform, such as a Pivotal Cloud Foundry. And that has helped streamline the development organization. In fact, the phrase for that is called DevOps, where developers through software are able to gain high rates of productivity and efficiency and resiliency in their solutions because a lot of the infrastructure need is actually handled within the platform itself, whether it's creation or spinning up of servers or taking them down. It's highly automated inside the platform as a service space. And then software as a service is where you actually experience the system of record, or the system of differentiation, or perhaps the system of innovation. Not as much there because of the nature of what you do with it being differentiated. Why would you go to a vendor of a software as a service for your innovative capabilities? Because everybody conceivably could get them. But a Salesforce.com is a great example of a software as a service. So you typically will pay based on consumption, whether it might be users or other, and they think about the infrastructure, they think about the platform. Now you may have to support it through your interoperability layer. So as an example, in our implementation of Salesforce, we are supporting that with 300 microservices. And so we have a lot of interaction between companies at the interoperability layer. We can take a release of Salesforce every 2 weeks because of the way that they've highly automated their infrastructure and management around it. So the question is, are you ready for change? When you talk about architecture and infrastructure, The book talks about these guidelines for planning an adaptable IT architecture and infrastructure. You should think about them as loosely coupled. Again, what are the major building blocks? How do they plug in to one another? You should set clear boundaries. So again, you think about what it does, and then how do they plug one to the other? And you create that boundary of separation so that if you want to remove one of those and plug something new in, this one is sitting on the boundary. And as long as the boundary is maintained, it doesn't matter what sits over here and replacing of that. And then obviously when you define your network architecture, you have to think about this concept of minimum necessary, because that is one of the foundations for securing your network. And a lot of companies are looking at software-defined networks to help them do that. And so when you look at an option, this idea of the pluggable components, typically you want to look at how standardized is it? What's its basis for standardization? Can it scale? How flexible is it? Can I unplug and plug in easily? Reliability is an important one. It has to have resiliency built into it. Maintainability, that gets toward how easy is it to make changes to it, and then clearly security. So when you look at an infrastructure component, and especially as you think about something like infrastructure as a service or platform as a service or software as a service, you want to, or frankly anything, it may be bespoke, custom developed, you want to think about these elements as you bring it forward. So let me shift now to information security. I could spend multiple lectures talking about information security. Ideally, you'll get the right perspective out of this discussion. And the question is, should you be concerned? And the answer is absolutely, you should be concerned. You should be concerned as somebody who's developing technology and thinking about IT strategy. You should be concerned as a technologist inside a company. You should be concerned as a citizen here inside the United States. And you should be concerned as an individual because I'm betting the majority, if not all of you, are running some form of personal network or connected to someone's personal network or some organization's network. And you have to think about these devices, how secure they are, how do you protect your information as an individual. The point to this particular slide is this. Oftentimes the entry into a system is done quickly and it's not discovered for a very long time. And worse yet, most of what exists today is what are referred to as advanced persistent threats. And this is the idea of they only have to find one entree, the beachhead, and once they get a foothold on the beachhead, they then have time and opportunity to understand where the weaknesses are, and then they move into the next town. And they then, again, understand where the weaknesses are and then move into the next larger town. And eventually they get to the cities, and then they get to the major cities, and then they get to the capital. And before you know it, your infrastructure has been compromised en masse. And so advanced persistent threats are real. They are difficult to defend against. They rely heavily on people. And at the end of the day, perhaps the only way to solve the problem is through enclaving and behavioral analytics. Enclaving is taking your most important information, placing it somewhere where there's the least amount of access to it. And behavioral analytics is watching how people behave inside the infrastructure and looking for patterns of behavior that are contrary to traditional or typical behaviors. Credit card companies with fraud detection are a great example of how that's being done today. If they see you at a gas station in Louisville, Kentucky, and all of a sudden they see a purchase from a gas station in Poughkeepsie, New Jersey. They can immediately act, reach out, and notify you. When I'm at a restaurant, I use my credit card. Literally before the waiter comes back to the table, I'm getting texted that my credit card has been used. So behavioral analytics combined with insights to action and enclaving are likely the way that we will at least um, begin to tip the scales on this cybersecurity challenge that we all face, whether it's individuals within our companies or as a nation of citizens, or in some cases within your respective nation as a citizen. So I alluded to this. Most companies rely heavily on an identifier and a password. And the majority of breaches are caused by an unknown, perhaps explicit exposure of those credentials. And then that's where that beachhead is taken advantage of. And if you look at most of the significant breaches that have occurred, it starts there. Eventually, the threat actor will, as part of an advanced persistent threat, identify an exploit and take advantage of it, ultimately getting to some level of administrative access. And once you have administrative access, it's extremely difficult to stop the snowball effect or consequence of that, which frequently is exfiltration of data. So there are lots of ways of stealing passwords. They can be phished from you, and there are a number of innovative ways. I will not get into details, but frequently you will have senior leaders who are targets, and it can be as simple as spoofing an email address to give the appearance that an email is valid from someone, and before you know it, they get into an exchange, and at some point the ask is made. It's either I need this or will you do that, and that's where vigilance wins out. And in our case, we have proactive phishing campaigns that we launch when someone unsuspecting doesn't do it intentionally, but does click on or look to respond to the will you do or can you ask in one of those. We will take them to a site where we educate them on why that's not such a good idea. Key logging exists. Staples, as an example, was compromised where threat actors found their way into the actual credit card device. Sitting on that was an EEPROM, which is an erasable, programmable, read-only memory chip. And what they did is they actually did a microcode upgrade on that chip, and through that they were able to capture the magstripe swipe stream of data, and then using the same microcode, they would port that up and out and exfiltrate it out of the company. So, you know, this idea of embedding things that watch and capture and send out is very real. Guessing at weak passwords is another one. Some of that is mitigated through requiring password changes, requiring complexity of passwords, not allowing them. I think in our particular case, we version passwords every 60 days. It has to be certain length, certain number of characters, numbers, unique character. and we don't let individuals reuse the same password. I think we up to 6, the prior 6 passwords, something on that order. And then this evil twin Wi-Fi is where you get individuals to believe they're on one network, but they aren't, and they capture credentials by spoofing a particular login, PNC Bank. As a result, you'll see some of these companies will, once they capture your credential information, they'll come back and they'll show you a graphic, and you're expected to identify that, yes, that is in fact me. And so they've put in multi-step logins to help detect that. You'll hear more about multi-factor authentication and biometric identification. But the point of this is, first line of defense is the employee and that login or security capability. And it's no longer an if you're going to be breached, it's a when. You cannot make a computer secure, it's just not possible. At some point, it connects to some device to interact with, and it's through that that an exploit can happen. And chief information officers, chief information security officers, and frankly, chief executive officers anymore will be measured. Their performance will not be measured by prevention as much as it will be measured by the amount of time it took to detect and the nature of the response that was taken. And you'll see 98, 97% of firms have been breached in some way, some larger than others. Yahoo is an example, Anthem is an example, Target, Home Depot, and so on. And perhaps one of the biggest challenges of this is that security can get in the way of productivity. And so the expression that I will use internally is, we want to take information security out of the experience while making the experience more secure. And so we really have to come up with a mechanism that simplifies as opposed to complicates, because this is a very complex device, yet it's been made very simple to use. And the same has to take place around security. So how do you know that you might be getting phished? Well, you'll get something, again, that's an ask for you. And you'll be told an account is being closed. You'll be told your email inbox is full. You've won something. You've got an inheritance or something that you have to give information in order to get that. Oftentimes they'll be asking for a credit card, and that's how your credit card number. You can be told that there's a product that's being delivered that it failed to be delivered, and here's how you can get information on it. You can look for hovering over a URL and you get a funky URL, or you can look at what looks like a legitimate email address, but when you go to details, you'll see it's a gobbledygook email address, and it's being spoofed. And this is, again, a familiar name, but a strange email address. Poor grammar and spelling. Hackers are quick and fast, and they don't always look at the work before they send it out. Again, something that's enticing you to act like a low price, and you have to be exceedingly careful with anything that comes through as an attachment, which then can turn into an executable. Now, why are folks doing this? Well, clearly there are state-sponsored actions. There's hacktivism, but frequently at the end of the day, there's a financial motivation. Credit card numbers that are valid can be worth up to $50 each. If you look at the Target breach, 2 million credit cards were sold for, on average, $20 a piece. You can get $400 on the street with a valid credit card number, which that's a pretty good return. Pay 50, get 400. And then some information, which is one of the reasons healthcare is targeted heavily, is that when you get more detail around an individual, inclusive of a social security number, you can take that single credit card and turn it into multiple financial opportunities, and therefore they will be sold for much higher, upwards of $1,000. Most of these things can be purchased on the dark web. Now, how do we think about practicing security? Well, you have to start with a strategy. You have to implement sound policies. You have to train the employee base because they typically are your first line of defense, and they are typically where the breaches begin with. You have to have the infrastructure to support it. You have to have ways of getting into your infrastructure securely, and you have to have ways of securing information at rest or when it's in flight. And then other investments that should be had. The book did not go into these next two, but I think that contemporary organizations should practice these. Your crisis management plans should be clear and developed, and clear response plans that should start with what is the CEO intent. If you want to look at what happened with Equifax, clearly they weren't prepared. It took them time to get prepared, and even when they did get prepared, the CEO intent wasn't clear because it was the consumers that had experienced the breach, not their institutional customers. And so the CEO intent was muddled, and obviously that's one of the contributing factors for why he's no longer there. Crisis management simulations that involve the incident response teams, the crisis teams, up through the significant event, which includes management team members, and ultimately to the board, whether you establish board liaisons for crisis management, significant events, or you have a committee, for instance, a technology committee on the board, but you should have that structure as part of your crisis management and response planning, and you should practice it at least twice a year. Focus on non-cyber crises and cyber crises, one each twice a year. Again, 2 crisis management simulations a year, 1 cyber, 1 non-cyber. Other things like third-party assessments, where you have someone try to purposefully break into your network through penetration testing, or you have someone come in and assess where you stand with strategy, policies, processes, training, tools, and so forth. I'm not going to spend a lot of time on the next few slides, but as you think about your policies, you want to start with, and again, the book didn't necessarily bring this out, but you want to look at a generally accepted industry-based security framework. In the payment card industry, it's called PCI. In healthcare, there's one called HITRUST. And so you want to use one or more of these in combination as a way of assessing where you are. You want to self-assess, you want to identify remediation plans, and you want to close gaps, and you should bring an external assessor in to make sure that you are being, not that you wouldn't be honest with yourself. Oftentimes they see different things than you do, and it's one of the reasons that physicians should not treat their own family, because they get used to the normal aches and pains and they miss something big. And so going to an unbiased physician creates the opportunity to catch something if it, as opposed to if you were attending to your own child. Likewise, security assessments, third parties. You want to do your security updates promptly. That's about patching. There's a lot of noise in the industry about the effectiveness of patching. Regardless, these are where exploits are identified and taken advantage of, and Equifax was a great example of the challenge around patching. And in the Equifax case, it was even more challenging because it wasn't patching an executable on a server. The platform itself is where the patch was required, and the exploit existed in sample code that was reused on the development platform. And so if you use a development platform and the majority of your applications have been developed using that, and the weakness is in the platform and it cannot be separately patched, and you must upgrade the platform in order to address that. That means you have to go through an upgrade process of your applications as opposed to patching a DLL, for instance, on a server in production. And so this means scan for vulnerabilities, use a third-party tool to scan for those vulnerabilities in your infrastructure, patch timely, have a mechanism to track those so you know what your average time to patching is, what your service level is based on severity of the threat and the exploit, and it's going to be a continual challenge across industry. Again, separation of networks helps because you have to jump from one to the other as opposed to once you're in, you're hopping system by system. So network separation helps with that. You know, constantly preach keeping passwords secret, manage mobile devices. Oftentimes, companies are putting security on personal devices. Our approach is we've taken secured apps that separate the experience that someone is having from their particular device. The example is using Citrix to support your VDI. You've got to have clear data use policies, retention, and disposal. You want to understand what's going on out in social media. You want to have social media policies as well. And then I reference this, use consultants, because oftentimes your view of this world is limited. It changes so rapidly. Access tools, you can physically separate and lock, which is good practice and should be done. Passwords, you can use biometrics as ways to gain access into systems. You want to think about things like challenge questions. I gave the example of, it wasn't a challenge question, but it was pick your graphic, or if you don't see your graphic, tokens. This requires you to carry a device. I personally, for financial reasons, have a token that I use on accessing accounts. Text messaging, which is an out-of-process, out-of-band way of validating that you're dealing with Brian, because if I'm logging into an account and I get a text message that says that here's my PIN to log into PayPal, let's say, it alerts me that somebody's trying to get into PayPal, and oh, by the way, they have stolen my credentials. So out of band is a useful way of doing that. Multi-factor authentication is again, it's a variant. It's a general class for describing these things. Multi-factor authentication basically says you know your ID and your password, and then you have something in your possession. The example of the out-of-band texting with it is multi-factor authentication. The example with the token I just showed you is another example of multi-factor authentication. And again, it's something that you have as opposed to something that you know, that allows you to unlock access if you have what you know and you have what you have at the same time, and they can be used to alert the individual that something funky is going on. Storage and transmission. Antivirus and spyware, although again, some folks, if you look at the major breaches, the majority of major breaches aren't happening because they weren't up to date on their antivirus or anti-spyware. Firewalls can prevent attacks in and can prevent information going out. So clearly you want to use firewalls. You also want to use what are called intrusion prevention services, which will look at the nature of the activity and identify signatures that suggest that something that may have made its way through the firewall is going on, and it will shut down that communication. Clearly, you want to look at your periodic review of system logs, because you may see an unusual high number of logins, for instance. and then alerts where you may use a third party who alerts you of certain activity that's happening out there that you don't necessarily see directly, but outside you can see, as an example, that you may be under the first part of a distributed denial of service attack. Encryption, I already spoke about this. Enclaving, putting the most important information in the safest place with the fewest people accessing it, encrypted, such that if it does be compromised, unless you have the encryption key, you cannot get value out of the data. If it moves, encrypted, and as long as, I shouldn't say as long as it is encrypted at rest and encrypted in flight, and you manage the keys in such a way that even if the data is taken, if you don't have the ability to unencrypt it, you generally will be better off than if you weren't encrypting. And encryption is applicable to laptops and desktops and servers and data and databases. So you want to use encryption. Enclaving is the idea that very few can get at it, and so you have a high degree of control over who does get at it. WEP and WPA are mechanisms for encrypting wireless networks. If you're running a wireless network at home, you should encrypt it using WEP or WPA. VPNs are virtual private networks. These are mechanisms to create a tunnel from point A to point B where what goes through the tunnel is encrypted. Ideally, you are using a trusted device. The trusted device is what sets up the VPN into your network, and the trusted device to your network allows it to act as if it's directly connected to your network, even though it may be remote and it may be going through public networks on the way. Okay, with that, I've run over today. I'd like to thank you. Again, fourth week, first case study is due, midterm exam, and as always, thank you for your attention. If you have questions, comments, or other, post them on the discussion thread for this week, and I look forward to talking to you for lecture number 5. If you have any questions, reach out to me via email. And again, thank you and have a great rest of day, whatever you're doing. Thanks.